Today, in today's maritime world, distance is a big factor. Understanding a physical system does not require close physical proximity like in the older decades. Today, digitalization, enables us to remotely observe and control even in domains where distance was a major obstacle. This is valid mostly for land and aerial vehicles, but in marine vehicles, we still have some problems with the distance. But still, we can remotely, at least we could remotely control ships. Even if the distance is far away, we could use satellites and control. And in older decades, we had to be inside the vessel to see what's happening, but now we do not have to be there to see what's happening, and that's the biggest change in today's technological world. Investigating the digital twin, the core concept of digital twin is actually universal, but its implementation in our industry is very different compared to, ground or aerial transport vehicles. Our industry is shaped by International Maritime Organization's regulatory framework, and that is only specific to our industry. Aerial or ground vehicles normally use SAE's, Society of Automotive Engineers classification framework, but our IMO has its own for the maritime industry. And that is called IMO's degrees of autonomy. The digital twin in our field is used very loosely, despite its growing popularity in marine industry. Many implementations actually rely on sole simulations, and they have no connectivity with the real world. And some others, they only reflect what is actually happening in the ship, but you cannot, control anything. You're just watching things happening in the screen as they go by, but you cannot control it. You cannot do anything, but you're just able to watch. Researchers usually tend to call all of these as digital twins, but actually they are not digital twins. And also, the good news is the digital twin is not the only concept in digitalization. There are also others which we are not generally aware of. Some people, of course, are, but the mainstream researchers in our field are not aware of this, I think. That's my observation. So we also need to focus some other concepts like digital model and digital shadow, besides the concept of digital twin. This webinar aims to establish clear definitions and propose a structured classification framework. Our framework consists of 6-level classification system based on these 3: digital models, digital shadows, and digital twins, and each are given with 2 progressive levels. But first, let's take a look at IMO's degrees of autonomy, and then we'll go further.